We all know sex makes life complicated. Boys often find themselves fighting over girls, while girls often have to choose a preferred mate among many suitors. But what if I told you that these stressful behaviours can be for nothing? That our sperm or eggs can have the final say in who we reproduce with? This is often the case throughout the animal kingdom, when a female's eggs come into contact with sperm from more than one male. In my model species, the blue mussel, sex means broadcast spawning, simply releasing sperm and eggs into the ocean where they must find each other and fertilise. This means that instead of competition among the males themselves for mates, there is competition among their sperm. I will work out whose sperm wins using a trick of mussel biology. In mussels, parts of the sperm that can be coloured with a green fluorescent dye get passed into the egg at fertilisation. By colouring a particular male's sperm and allowing it to compete with non-coloured sperm from other males, I will work out his competitive success by counting fertilised eggs that are coloured. This will let me determine what makes a successful sperm. Are they fast swimmers, slow swimmers, curvy swimmers? Maybe they have long tails or big heads. But it's not just about what the boys can do. Females can often influence these competitions using mechanisms that let them choose sperm from the males they prefer. Now, in many animals, eggs release chemicals that attract sperm towards them, useful for broadcast spawners. This is known as sperm chemotaxis. And in these mussels, it's recently been found that a male's sperm will swim toward the chemical halo of eggs from some females, but not others. This colouring technique will allow me to determine whether this lets the females choose sperm from particular males when they're in competition with sperm from other males. But why should we care about sex in mussels? Well, it's not just mussels where sperm and eggs can determine who reproduces with whom. In fact, broadcast spawning is the ancestral animal mating strategy, and the sperm-egg processes that are important in these systems have been passed down the generations to many of today's animals. For example, humans aren't broadcast spawners, fortunately. But sperm chemotaxis does occur in humans. Until now, however, we've had no knowledge in any species of the role it might play in mate choice. Using this unique model system to directly investigate these roles will provide the basis for greatly improving our understanding of compatibility and fertility of different partners in many animals, including us. Thank you.